So how do I simplify a radical? I take the number that's underneath. I write it as a perfect square times the leftover. That's where that pre-homework came in. Properties of multiplication of radicals allows me to break it into two parts. The square root of the perfect square times the square root of the leftover. Square root of 100 is 10. Square root of 3, it's the leftover, so it's just the square root of 3. So what we were doing before were radicands. Now, you don't have to put all these steps in, but I always start out with this first step. Always. I break it into two pieces. The perfect square, cube, fourth, whatever it is, and the leftover. Then I know how the two pieces are going to break apart. 27. I want the square root of 27. I break it into two pieces. The square root of the square and the leftover. I use the product rule for radicals. Since this is a multiplication, so it's 9 times 3. So square root of 9 times the square root of 3. Square root of 9 is 3, and the leftover is the square root of 3. So that is simplified as much as I can. Now here's the cube root. I'm going to do the same thing. The cube root, I break it into two pieces.
So those three can't cancel out?
No. The perfect cube and the leftover. Well, if I get down my list and what we did earlier, the cube in 250 is 125. The leftover is 2. X cubed is a cube. So what's in front is the perfect cube. What's in back is what's left over. So this turns into the cube root of 125 x cubed times the cube root of 2. Why? Because there's a times in between those two. Now I take the cube root of 125, which is 5, and the cube root of x cubed, which is x, and then the leftover is the cube root of 2. Now many of you, and for myself, I only need to take it down to this, and then I basically know I'm taking the cube root of this front part, and then this back part is what's left. But the concept is, it breaks into two pieces. That's the concept.